Hi guys, welcome to Piece of Code and welcome to this particular lecture. So in this particular lecture we are going to see some additional binary operators. Okay, so we covered a lot of operators like unary operators and everything and arithmetic operators. So we're going to complete the remaining binary operators, which are relational operators, logical operators and equality operators. Very easy, and you'll get some questions from this section and you will be able to answer it quite well if you understand everything. Okay, let's move forward. Now moving on to relational operators. So relational operators compare two expressions and return a Boolean value, right? Yeah, that's what it is. It's as simple as that. The first four relational operators, if you see this particular table, are applied to numeric primitive data types only, right? So basically that you see over here, these are applied to numeric data types only. Okay, like greater than, less than, greater than, equals to, less than, equals to, and some examples which be like 5 greater than 3 or 3 greater than equals to 3, something like that. If you have these kind of numeric expressions, then you can easily use relational operators, and basically they return a Boolean value like true and false. So this will be true and this also will be true, something like that, right? Very easy to understand. Okay, now let's see some examples, right, of some relational operators. It's very easy to understand, right? So let's see some examples right now. So let me just go and open this particular thing. So let us see some examples. So for example, I take int x equals to 10, y equals to 20 and z equals to 10. So if I do s.o.pln, right, if I do, for example, s.o.pln in short, it is system.out.println. okay. So if I do x is less than y, right, so it basically outputs true, right? Then if I do, for example, x less than equals to y, right, then basically it says true, because x is 10 and y is 20, so it is obviously true. Now if I do, for example, x greater than equals to z, so basically it is also true, because greater than or equals to, right, so it can be greater than or it can be equal. So as 10 and 10, so it is equal, so it is true. Another example can be x greater than z. In this case it is false, because obviously x is not greater than z. So these are some of the examples that you can see regarding relational operators, and basically identifying relational operators in the exam is very easy. It's a piece of cake. You should not give the exam if you are not aware of relational operators, because it's so easy, right? Now talking about another relational operators that we just saw here, that is an instance of operator. So let's talk about this instance of operator, right? And as this instance of operator states, basically the instance of operator, it is true if the reference that points to is an instance of a class, subclass or class that implements a particular interface, or which is shown by this particular thing B, as it is written over here, right? I've written this over here. What does this thing actually mean, right? So it practically states that if you create an instance of a class, so basically we are checking if that particular instance belongs to that class or not. Let's see an example to understand. It is not that much necessary for the OCA exam, but it may be necessary for the OCP exam. So if you are appearing for the OCA exam, it is fine, don't have to understand in depth. But let's take an example. So if I have taken a class A and I have created an instance of class A, for example, class A equals to new class A, right? If I have done this thing, so basically if I check A instance of class A, right, this will return true, because obviously A is an instance of class A, right? That is also true. Now for example, another class is present, that is class parent, and this class A actually inherits from class parent, and this is the inheritance concept. It means that class parent is the super class of class A or the super parent of class A. Then what we can do is we can write this thing also, parent P equals to new class A. This is also possible, because as parent, this parent class, right, is the super class of class A, it can hold this instance of class A, and it is also completely possible. And this particular concept is known as implicit downcasting. Okay, so basically we are doing, what we are doing is basically we are holding this new class A's object in parent P. So this is the reference of parent P, right? But you can still hold this class A because it is the parent class of class A, right? It is possible. So in this case, if I do this thing, right, P instance of class A, this will also return true, because even though parent P is holding an instance of class A, still this object is instance of class A, right? The main thing is that we do not care about this reference, because reference are just pointers to the object, right? We are not caring about the reference. What we care about is this particular class, this class instance, that new keyword we use, right? This is the actual instance, right? Because this is the object. So basically the instance of operator checks if a particular whatever reference you have taken is an instance of that particular class or not. In this case, even though the reference is coming from parent B because it is the superclass of class A, even though that is the case, still class A, this parent P is an instance of class A because this is where we are creating the object. That's how instance of operator works. And the same is the case of interfaces, where we just use implements instead of extends. So I just wanted to shed some light into this instance of operator, even though it is not important for the exam, but just keep in mind that this is how it works, right? So it should make some sense right now. Okay, now let's talk about something known as logical operators. And something about logical operators is basically this thing. We have an AND operator, we have an OR operator, and we have an basically inclusive OR, and we have exclusive or it is also known as a XOR operator, right? If you see this particular diagram, right, so we see this is the AND operation over here, the AND operation, and this is the OR operation, and this is the XOR operation or the exclusive OR operation, right? Now in this case, this is the truth table or the truth diagram, whatever you want to say. Now it says if X is true in the case of AND operator, right? This is the AND operator. In the case of AND operator, it says if X is true and Y is true, then the result becomes true in this case. X is true, Y is false, result is false. False and true, false. False and false, false. So if you see, in only one condition, the result is true, where both X and Y are true. So you can just say if X and Y are true, then the result is true in the case of AND operator, right? This is the case of AND operator. Now talking about this thing, right, talking about basically the OR operator. In the OR operator, what is happening, it is basically the opposite of the AND operator, right? It is the opposite of the AND operator. Just let me select this. Now in this case, if it is true and true, we get true over here. If it is true and false, we get true. If either one of it is true, we get a true. In this case, this one Y is true, so we get the result as true. In this case, both are false, then we get a false. So in the case of OR, if for example either one is true, then result is true. That is the case of OR. Now talking about XOR. XOR is particularly easy to understand. It's an exclusive OR. So if you're going to see, if it is true and true, it is false. If it is true and false, it is true. If it is false and true, it is true. If it is false and false, it is false. So basically, when we have two similar bits, and I'm talking about bits because we can consider one as true and 0 as false, right? So if there are two similar bits, for example true and true, the result is false. And if there are two similar bits like false and false, then it is also false. So to get a true value in exclusive OR, you just have to flip one bit. For example, if it is true false, then it is true, and if it is false true, then it is true. So that is about exclusive OR operation, right? So that is what I meant by that. So by understanding these logical operators, truth table, you will get the idea to solve all the questions that may come in the exam. Now finally, there is another special kind of logical operators that we also known as short circuit operators, and we spell it like this: short circuit Now why is it known as a short circuit operator? Let us understand the particular thing. Let's take an example like boolean x equals to true or y less than 4. In this particular scenario, what happens is that you will think that it's an OR operation, but you can see that here are two ORs, right? Because if you see this truth table, there was only one OR, and this is the normal OR operation that we do in a Java, but there is two ORs over here. What does two ORs mean? This means as short circuit or SC. Now what does this short circuit do? It evaluates one side of the expression. तो इस तरफ का वो evaluate करेगा. So one side of the operation it does evaluates. So if that particular side of the evaluation returns the result, then actually there is no need to evaluate the next expression. It means that in the case of OR, right, if either one of the bits is true, then basically the result is true. So in the case of true false, if true, there is one true present, then the result is true. In this case, we have already specified that this side of the expression is true. So does it needs to check this side of the expression? No, because we have already got a result from this side. So the result will be true. So it will not check this side of the expression. But if you had done this thing, true or y less than 4, if you had done this thing using the normal OR operation, then this side will be evaluated and this side also will be evaluated, even though this side evaluation is not necessary. So this is known as a short circuit. If you get the result from evaluating one side of the expression, then the second side is not evaluated anymore. That is what we really mean by the short circuit thing. So ये घर वाला short circuit नहीं, it is not short circuiting in your house. It's a normal thing about short circuiting operators. I make a lot of lame jokes, Okay, so let's see some examples right now. Okay, so basically a more common example of where short circuit operators are used is checking for null objects before performing an operation. Now what do I mean by that? Let's see this example over here. So basically there is some kind of an object, okay, and there is an if condition. If x not equals to null and x dot get value. So this is a method in the particular class, for example x, whatever the instance is, right, and get value is less than 5, then we do something, right, do something. Okay, now in this particular example, if x was null, then the short circuit prevents a null pointer exception. Why? Because since the evaluation of x dot get value less than 5 is never reached, right, because in this case if the x value is null, then it will just evaluate this expression, and if it is null, we get a false over here. And according to the AND operation, if one side is false, then basically the whole result is false. So there is no need to evaluate this expression. So if this was false, right, so basically it will not get evaluated, this side will not get evaluated, and thus it will prevent a null pointer exception. Okay, but if it had been this thing, if it had been a single AND, then this side would have been checked and this will return a false, right, this will return a false. And when we go to this side, right, this side will also get evaluated because it's a normal AND operator. Okay? Now when this side gets evaluated, we get a null pointer exception because this particular x is particularly null, and when you call a particular method or a class variable on a null object, then you will get a null pointer exception. So that is why this thing happens. So basically be wary of short circuit behavior on the exam, okay, because they can test you. Even though this is a very good feature, they can test you on the short circuit exam questions, right? And let us see an example how they can trick you or test you. Let's see an example. So int x equals to 6, right, and we have boolean y equals to x greater than equals to 6, right, or we can just say plus plus x less than equals to 7. So this is an expression that that one question may come. So question, right, and then they say, okay, what will be the output? So s dot 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 pln x, right. So this just stands for system dot out println. Now what happens in this case? Can you just guess the output? Because x is greater than equals to 6 in this case, right, this basically returns a true, right. The increment operator that is present over here does not execute at all. Why it does not execute? Because as this side of the expression returns true, then basically this side is not evaluated at all. So this plus plus never happens. So the output is basically 6. But if there had been one single operation like the OR operator, like over here, then this particular operation will happen. So even though this returns true, this side will get evaluated. So plus plus x will happen. So plus plus x means that plus plus 6, which is 7, 7 less than 7, this side also will return true. In that case, the output would have been what? 7, right? So make sure you be very wary of whatever operators you see, especially of the short circuit operators, because the short circuit operators are a very cumbersome type of operators if you are not, you know, attentive in the exam. So make sure you are attentive in the exam, otherwise you'll lose some precious marks. Okay, let us talk about the last type of operator that we are going to discuss, that is known as equality operators. So basically equality operators. So determining equality in Java can be a non-trivial endeavor, as there is a semantic difference between two objects are the same thing, and we are going to discuss this in detail when we are going to talk about objects, classes and strings, right? You'll understand that later on, but for now let us do this thing. So there are two expressions, right? Two objects are the same. There are a lot of what we say debate going on that two objects are the same. How two objects are the same? We are going to discuss that later on. And two objects are equivalent. Okay, both are different things, but it kind of sounds the same thing, right? It is further complicated by the fact that for numeric and Boolean primitives, right, there is no such distinction because for numeric both equivalent and same means the same thing, and for Boolean also both equivalent word and the same. So these are two words. They differ in the case of objects and strings, but these two words are practically same for primitive types and for Boolean types. Now let us try to understand. Let's start with the basics. The equals operator, which is equal to like this, and the not equals to operator, which is this thing. Now, like the relational operators, they compare two operands, right, and return a Boolean value about whether the expressions or values are equal or not equal. Simple as that. Now, the equality operators are used in one of the three scenarios. Do I have the slides for the three scenarios? Oh, I don't have the slides for the three scenarios. I have to write it down now. No worries. So, the first scenario, let us try to understand. So, comparing two primitive types, if the numeric values are of different data types, then the values are automatically promoted as previously described. So automatic promotion. First one is automatic promotion. What does this thing mean? So let's take an example. Examples are good. 5 equals to 5.00 or 0. This will return true. Now as I've already told you, right, the left side is promoted to a double. Now ये numeric promotion से भी related, it is also related to numeric promotion, where in numeric promotion what I say, that out of the two data types, if there are numeric data types, so the data types are promoted to the larger data type. So this is a double data type and this is the integer data type. So this one will be promoted to a double, and basically we are comparing 5.0 equals to 5.0. So which is true. So this becomes true. So don't confuse that this is a double and this is an integer. We are comparing it, so it may return false. No, it will return true because it will convert it to a bigger data type. So that was one, automatic promotion. Second, comparing to Boolean values. So comparing to Boolean values. So basically it's a very easy thing. If you are comparing two Boolean values, if it is true, then basically it is true, otherwise it is false. Simple as that. Now another rule that I am talking about is this thing, comparing to objects including null and string values. So objects and strings, this is where things get trickier, not thicker. यार क्या लिख रहा हूँ मैं, trickier. And for this particular concept we are going to discuss this in detail later on, but for now just understand this rule and this rule. Okay, now let's see some examples which will just clarify your mind a little bit about what I was just trying to say. ठीक है, थोड़ा सा examples देख लेते हैं, going to see कैसे सवाल आने वाले. So for comparisons or for equality are limited to these three cases. You cannot mix and match types. Now let us see an example. So if I do this thing, boolean x equals to true, which is kind of fine because you're just assigning it. But if you do this thing, ये अगर मस्ती करते हो आप, then this doesn't compile, right? Doesn't happen. So if I do this thing, boolean y, for example, मैं इधर जाके ये करता हूँ, boolean y equals to, for example, false, and then not equals to Akash. So data types matter. आप ऐसा नहीं, ये same type of data नहीं, this is a boolean and this is a string, so it also doesn't compile. My handwriting is really bad. Okay. Now similar thing, obviously if you do this kind of stuff, this basically will not compile because we are just comparing different data types and it is not possible. Now pay close attention to the data types when you see equality operators in the exam. Okay. Now let us see another example which can trick you. जैसे हमने ये सब examples देखे where it doesn't compile. So another example is there where you will think that okay, this will also not compile, but it actually compiles. So the examples can be like this. Boolean y equals to false, and then we have boolean x equals to y equals to true. हमने ये example we had discussed later on, previously, and if you remember that example, you will be easily able to answer this question. If I say s.pln x, then what will be the answer for that? This will be returning true. Why is that? Because in this case we say y equals to false, तो यहाँ पर y assign हो गया false को, but over here हम लोग क्या कर रहे हैं, पहले तो we are doing y equals to true. It means that y has been assigned the value of true now, and then we are assigning this y value to x here, so the x also becomes true and y also becomes true in this case. So we are displaying x which is true. So don't confuse this thing question, very easy question. Don't confuse it like it will be an compilation issue. Okay, very easy to understand. Okay, now for object comparison, the equality operator is applied to the references to the object. थोड़ा सा objects के बारे में भी discuss कर लेते हैं. So when we are comparing about objects, right, when we are discussing about objects, the equality operator is applied to the references to the objects, references, and I am saying a little bit of stress on the references so that you never forget this thing. So हमारे पास दो चीज़ें हैं कि reference है and another thing is instances. So I am focusing on the references right now, and I have already explained what is the difference between instances and references. Let's see an example of what I mean. That in this case, what I try to mean is that if two references are equal, if and only if they point to the same object. Okay, that's why I said references. Now see an example over there. तो ये एक फाइल के रिलेटेड एक this is file related object, so don't worry, we are not going to use files right now. I'm just creating an object. So file x equals to new file, for example test.txt. So this is a file. So this is a syntax to open a file, and I have another one. So file y equals to new file, just creating objects right now, test.txt, same file we are opening another time. Now if I do file z, so this is z equals to, for example, x and if I do two things, s.o.pln, if I do x equals to y, and s.o.pln, if I do x equals to z, for example. So this was z. Now what can be the output? Guess the output. In this case it will return false, and in this case it will return true. Now it can be a little bit difficult to understand, but this is actually the case. Even though all of the variables point to the same file information, they both point to the same file information, only two, x and z, are equal in terms of equals, which is the double equals, right? And how does this thing mean? So let me just remove this thing and you'll understand what I really mean. So basically in the heap, right, objects are created in the heap, right? So this is our heap memory. So when I create an x, right, so basically it is a new object has been created and x is pointing to that object, and when I created y, y is pointing to another object over here. Cool, this is cool stuff. So basically, even though the file information we are opening text.txt, right, test.txt, even though that is the case, we are opening the same file, but different objects are created. This is a different object and this is a different object. Understand? Well, so when we do x equals to y, they are pointing to different objects, so that is why this became false, right? This became false as we saw over here. Now what happens when we introduce z in this case? When we introduce z, it says z equals to x. So basically x is pointing to this object. So now what happens when we say z equals to x, we kind of create a copy. So basically z will also point to that particular position of that particular object. So both x and z are not pointing to the same object, this one. So as x and z are pointing to the same object, so when we do x equals to z, we get true as a value. Okay, very good thing. So this is how they can trick you in the exam. If you understand what it is actually happening, very easy to solve that question, and you get 1 mark over here. And basically it is also very true, very easy to identify also. So in the next chapter, we are in the next chapter, which is basically core Java APIs, we will continue the discussion of object equality. So by introducing what it means for two different objects to be equivalent. So अभी मैंने आपको सिर्फ idea दिया, I have given you an idea of what it means, but in the next chapter we are going to dig deeper into this concept, and we are also going to cover string equality, which is one of the most important things you need to know. And string equality के ऊपर I think from in the exam you will get 3 or 4 questions, I think so, because it is very important. I don't know why they just like this string equality concept, right? So because I don't know why. So basically this is also important. Okay, so that was all about this particular video and this particular lecture. So basically we covered all the operators. So we covered unary operators, we covered relational operators, we covered logical operators, covered mostly all of the operators that you need for the exam. And from the next session we are going to cover statements and loops, right? And we are going to see all the questions that may come from that particular topic. Alright guys, so that's it from my side, and till then, bye bye.